Right, in this video we'll be discussing binomial expansion. Under it it talks about Pascal triangle, discussing about Pascal triangle, then the approach, combination approach, then the third one, the series approach, and finally discussing linear approximation, linear approximation. But let's take a quick recap on factorization, because an extension to factorization is binomial expansion. When you have your power to be maybe a large number of power, when your n is greater than, let's say, greater than 10, 11, 12, how do you expand that? So with the help of binomial expansion, you could be able to solve problems relating to power that are more than 5 or 5, 6, 7, 8. You get that? So now let's take a quick recap on factorization. When you are given x plus y raised power, let's say raised power 2. Now in order to expand this, discipline means x plus y into bracket x plus y. When you open your bracket, you should have your answer to be x squared plus xy plus what, y raised power 2. So this will be x raised power 2 plus 2xy plus y raised power 2. Okay, this is normal factorization that we are familiar with, but another way to solve this without going through this process, we could use any of these methods. We have Pascal triangle, combination approach, the series approach, and linear approximation, depending on the given problem that we are encountered with. Alright, now we take it from here. Pascal triangle. Okay, how does Pascal triangle formed? Pascal triangle represent the coefficient of given variable in a factorization. So when we say coefficient, these are the values attached to a given variables. So that's coefficient. Take for instance, okay, now n raised power 0. If I say x raised power 0, that's what? That's 1. Okay, the coefficient here of x here is 1. X raised power 0, the coefficient there is 1. If I have x plus y, the coefficient of x here is 1, and the coefficient of y here is also 1. Then if you extend it further, repeat this one, repeat another one, then this one plus this one, it will give you 2. That represents x plus y, all raised power 2. Then the power here is raised power 2. Then these are the coefficients of x plus y raised power 2. Then if you go further, add 1 there, add another 1 there. Okay, this one plus this 2 here, you have 3. This 2 plus this 1 here, you have 3. That's for x plus y raised power 3. All these values that you are seeing there, they represent the coefficient of x and y. Then I could still go further by saying 1, repeat the 1 again. 1 plus 3 here, you have what? 4. 3 plus 3 here, you have what? 6. And 3 plus 1 there, you have what? You have 4. That's for x plus y raised power 4. Then if you continue that way, you still arrive at something, the coefficient. This represents coefficient. So we are using this. Let me use another method to make it more simpler. Okay, we're solving this without not expanding, open the brackets. So I want to use Pascal triangle solving this expression. I know we are all aware of this, but this, okay, how did I use Pascal triangle? Okay, raise power 2. One thing here you do there is that you give the highest power here is 2. So one of the given variables x and y, or one of the variable, the power will be increasing and the other power will be decreasing. When I mean increasing, decreasing, I'm going to demonstrate it here now. So since that, then one of the condition there is that when you are distributing the power, the value given must not be greater than the power given the question. The power that you have here is 2. So if you are distributing 2, what you are distributing should not be more than 2. That's what I mean. Take for instance, I'm having x. I could give it this way. X should take the whole power, okay, which is 2, meaning that there will be nothing left for y. There will be nothing left for y. That will be y raised power 0, right? Then if you look at x takes the value, the power of 2, y takes 0. Then what will happen there? The power of x will start to decrease. Then the power of y will start to increase. That will be x raised power 1 from 2, 1, y will receive 1, plus x raised power 0, y raised power 2. Do you get that? So if you continue, therefore, that actually means x raised power 2 multiplied by y raised power 0. N raised power 0 is what? Is 1. So x raised power 2 times 1 multiplied by 1, that's x raised power 2, plus xy plus x raised power 0, that's 1. This will be y raised power 2. So all you just need there is that, how do I apply Pascal triangle here? Since I'm having 3 variables, 1, 2, 3, then the coefficient of these 3 variables that I'm having here, and these factors that I'm having here, these are the coefficients. So since I'm dealing with raised power 2, then this raised power 2, I could have 1, 2, 3. Then there are 3 numbers, you could see there. Then I could just insert it here by saying this 1 and this 2 and this also 1. Therefore, then multiply this x raised power 2 plus 2xy plus y raised power 2. Therefore, the expansion of x plus y raised power 2 is equals to x raised power 2 plus 2xy plus y raised power 2. That's a brief of Pascal triangle. That's a brief of Pascal triangle.